Okay, welcome to the next video on polynomials. So what we're going to look at in this video is zeros and factors of polynomials, and we're going to be focusing on cubics for this video. So we're not worrying about anything higher than a degree of 4. Just to start off with, let's just go back to the general form of a cubic, which is y equals ax cubed plus bx squared plus cx plus d. Just want to introduce the factorized form, which is very similar to the factorized form of a quadratic. It's y equals a, and then multiplied by all of the factors. So here I'm going to use x take alpha, x take beta, and x take gamma. Okay, and we know from our work with quadratics that these basically tell us the zeros. So these are the points where the cubic crosses over the x-axis, are going to be alpha, beta, and gamma. Okay, so how is that useful to us? Well, let's say I get told to find all cubics with zeros 1, 6, and -3. Okay, so I want to find all of the cubic equations that have those zeros, and I'm going to use a trick for doing this in that I'm going to use this number a to cater for the fact that that covers all of the possible cubics. What I'm going to do then is I'm going to say y equals a, and then each factor is going to correspond to one of the zeros. So I'm going to do x take 1, x take 6, and x plus 3. And that's actually all we have to do for that particular question, because we know that a covers all of the possible cubic functions that have those zeros. Depending on what a is, that'll change the shape of the cubic, but the zeros will still match up, just like with the quadratics as well. Now this process does actually get more complicated if we have complex roots. So remember here, when I say complex roots, I'm talking about complex zeros for the function. Now, if we know that we've got complex roots, there's a little trick that we're going to use in order to find the cubic equation. To do that, I'm just going to backtrack a little bit and go back to quadratics. So let's think back to quadratics. Let's say we've got y equals ax squared plus bx plus c. And let's say that if we factorize that, it will come out to x take alpha, x take beta. And we probably will leave it like that. If this is the case, then one of the things that you can define or derive for a quadratic says that alpha plus beta has to equal -b over a. And alpha times beta has to equal c over a. So make sure you write that down because it's quite useful. Now you'll see that looking at this, if a equals 1, then the sum of the two zeros is going to be -b, and the product of the two zeros is going to be c. So that's a little trick that we're going to use when we look at cubics, and I'll just do an example of that in a moment. So my example says that I have zeros of 2 over 3 and negative 2 plus or minus root 3. So there's 3 zeros for this function, so it's going to be a cubic of some sort. Well, let's start off by worrying about the first 0, which is 2 over 3. That means that it's got to look something like this. Y equals A, and then I'm going to have a factor 3x take 2, because if 3x take 2 equals 0, the only way that's possible is if x equals 2 over 3. So I've just jumped straight to that. And what I'm going to do now is I'm going to say, I don't know what this is multiplied by, but I know that it's got to be a quadratic. Because a quadratic multiplied by a linear function will give you a cubic overall. So, let's first of all look at the sum of our remaining 2 roots. So negative 2 plus root 3, take 2, take root 3. Actually, no, that's right. The sum is equal to negative 4. And from what we've just learned, if we're trying to find a quadratic with those 2 roots, the sum is going to be equal to negative b. And that tells us that b equals 4. If we go to the product of those 2 roots now, and we multiply those together, we get 4, negative 2 root 3, 2 root 3, take root 3 will give you 0, and then root 3 times negative root 3 will give you negative 3, which is 1. And we know from what we were just doing before with the quadratics, that the product of the roots has to come out to c. So that tells us that c equals 1. So if we go back to our quadratic now, we know that it's going to look like x squared plus 4x plus 1. So b and c have come from the sum and the product of those 2 complex roots. So again, this is just the process that you need to use if you've got complex roots. So that's where you've got the square root of a number in the roots. Okay? That's all for this video. Thank you for watching.